Hi guys, in this video we'll be taking a look at quadratic inequalities. I will advise you pay attention to the details on how you attack questions on quadratic inequality, and this will even help you when solving questions as high as cubic inequalities or when the unknown is raised to the power of 4 and so on and so forth. Now whenever you see a question like this, starting with the very first question, x minus 2 x plus 3 to be greater than 0. Now on no account should you try something like this. So we are solving this. On no account should you try something like this. X minus 2 is greater than 0 and x plus 3 is greater than 0. This is partially correct, but it's not correct. So the only reason, like I've mentioned before, why we do something like this, x minus 2, x plus 3, for example, if this is equal to 0, the only reason why we say x minus 2 to be equal to 0 and x plus 3 to be equal to 0 is because for the product of two numbers to be equal to 0, one of the numbers has to be 0. So it is either this guy is 0, then the product of this guy must be 0, or this guy is 0, then the product of this guy must be 0. That's why if you put a 2 here, this automatically becomes 0. So whatever this guy is, the product will be 0. If you put a minus 3 here, this guy automatically becomes 0. Whatever this guy is, the product must be 0. So that's why we do something like this. But in this case, x minus 2 multiplying x plus 3 to be greater than 0. You can't just say x minus 2 to be greater than 0 and x plus 3 to be greater than 0. This is correct, but there's a reason why this is correct. And this is just one of the solutions of the two possible solutions to this question. Now you are given a quadratic equation, you are given a quadratic inequality, and during the course of solving, you factorize and you got to this point. How do you approach it? So that's what we are looking at. Now as you can see on the board, x minus 2 x plus 3 to be greater than 0 simply means the product of x minus 2 and x plus 3 must be positive. That's the meaning. For x minus 2 to multiply x plus 3 to give you a value greater than 0, the product of these two guys must be positive. Now, what does it take for the product of two guys to be positive? The product of two numbers can be positive only when one of the number is positive and the other number is positive, or one of the number is negative and the other number is negative. I repeat, the product of two numbers can be positive only when one is positive, the other is positive, or one is negative and the other is negative. So I can say for the product of these two guys to be greater than 0, it is either x minus 2 is positive and at the same time x plus 3 will also be positive, or x minus 2 will be negative and at the same time x plus 3 will be negative. Now you can see that when I told you that this is greater than 0 and this is greater than 0 is one of the solution, I was very correct. So you can see that this is positive and this is positive, it will give me a product greater than 0. This is negative and this is negative to give me a product greater than 0. Now we have to solve for x minus 2 being positive and x plus 3 being positive. We'll keep the answer. We also solve for x minus 2 being negative and x plus 3 being negative. Now let's start with x minus 2 being positive and x plus 3 being positive. So if x minus 2 is positive, it means x minus 2 must be greater than 0. This is the meaning. X minus 2 must be greater than 0, and at the same time x plus 3 must be greater than 0. That's the meaning. X minus 2 must be greater than 0, and at the same time x plus 3 must be greater than 0. Now if x minus 2 is greater than 0, that simply means x is greater than 2. And if x plus 3 is greater than 0, that simply means x is greater than minus 3. So x must be greater than 2 and at the same time x must be greater than 3. We have to combine these two inequalities together. Now how do you combine? We are looking for those values of x that are greater than 2 and at the same time greater than minus 3. Values of x greater than 2 and at the same time greater than minus 3. So I will explain this in two ways. One way to explain this, let's start with numbers greater than minus 3. You have your minus 2, you have your minus 1, you have your 0, you have your 1, 2, 3, 4, 5, 6, 7, down to infinity. Now you can see that I have listed the numbers that are greater than minus 3. At this point, s is greater than minus 3. Very correct, but s is not greater than 2. At this point, s is greater than minus 3, but s is not greater than 2. At this point, s is greater than minus 3, but s is not greater than 2. At this point, s is greater than minus 3, not greater than 2. As you can see, I'm just listing this integer as greater than minus 3 to make things easier. At this point too, s is greater than minus 3, but s is not greater than 2. But the moment you get to this point, s is greater than minus 3, and at the same time, s is greater than 2. Now you observe that if I list all the values greater than 2, I'm going to have 3, 4, 5, 6, 7 down to infinity. Now, what are the values of s that are greater than 2 and at the same time also greater than minus 3? It is obvious that for any value of s greater than 2, that value will also be greater than 3. So if I'm to combine these two inequalities together, if I'm to combine s greater than 2 and s greater than minus 3 together, s is greater than 2 and s is greater than minus 3. The values of s that are greater than 2 and also greater than minus 3, if I combine them, you see that the solution is simply x is greater than 2. That's the solution to the first one. So once s is greater than 2, the product of these two guys will be greater than 0. Once s is greater than 2, the product of these two guys will be greater than 0. So we can check. Let's pick a value greater than 2. If I pick 3 and put 3 here, 3 minus 2 will give us 1. Pick a 3 and put it here. 3 plus 3 will give us what? 6. So what is 1 times 6? It is greater than 0. Pick another number greater than 2 like 10. 10 minus 2 is 8. 10 plus 3 is 13. 8 times 13 will give you a value greater than 0. So you can see that for any time s is greater than 2, the product of these two guys must be greater than 0. So that is one of the solutions to this quadratic inequality. Now, another way to explain that the combination of these two guys is s is greater than 2, I will present them in my number line, pick a point for minus 3 and pick a point for 2. Now, where do I have x to be greater than minus 3? X to be greater than minus 3 will start from here to the right. Where do I have s to be greater than 2? S to be greater than 2 will start from here to the right. Now ask yourself, on this line diagram, at what point is s greater than minus 3 and at the same time greater than 2? S is greater than minus 3 and at the same time greater than 2. If you look at this particular line here, you can see that s is greater than minus 3 and s is greater than 2. But from here to here, s is only greater than minus 3. So for s to be greater than minus 3 and also greater than 2, it means that s must be greater than 2. S must be greater than 2, and that is the solution. Now let's move on to the next one. The next one states that s minus 2 must be negative and at the same time s plus 3 must be negative for the product to be greater than 0. Because a negative number times a negative number will give you what? A positive number. So let's put that s minus 2 is negative simply means s minus 2 is less than 0 and s plus 3 must also be less than 0. So this will give us x is less than 2 and x is less than negative 3. Now if we follow exactly the same approach, at what value of x or what range of values of x will s be less than 2 and at the same time s will be less than minus 3? If I combine them the way I combine this, the answer will be what? X is less than minus 3. Once x is less than minus 3, x must be less than 2. Once x is less than minus 3, x must be less than 2. So when x is less than minus 3, that is the solution of x is less than 2 and x is less than minus 3. Now we can check, pick any value less than minus 3 and put it here. So we can pick a minus 5. Minus 5 minus 2 is minus 7. Minus 5 plus 3 is minus 2. Minus 7 times minus 2 will give you a value greater than 0. Pick another bigger value less than minus 3. Your minus 10 here will give you a minus 12. Your minus 10 here will give you a negative 7. Your negative 12 times your negative 7 will give you a value greater than 0. However, if you pick any value that is not greater than 2 and not less than minus 3, you see that you'll be getting answers not greater than 0. So let's pick a value that is neither greater than 2 and is not less than minus 3. So those values will lie between minus 3 and 2. So we can pick 0. If I put a 0 here, 0 minus 2 is minus 2. 0 plus 3 is 3. Minus 2 times 3 is not greater than 0. Pick 1. 1 is not greater than 2. 1 is not less than minus 3. Put your 1 here, you have a minus 1. Put your 1 here, you have a 4. Minus 1 times 4 is minus 4, and it is not greater than 0. So you can see that the solution to this first question is x is greater than 2, comma, x is less than minus 3. And you don't combine this type of inequality. You leave your answer this way: x is greater than 2 and x is less than minus 3. That's the solution. Now, if you are writing an OBJ exam and you don't have to go through this stress, you are writing an OBJ exam, you don't have to go through this stress of bringing out the details why this answer is correct. Just take note that whenever you have x minus a, multiplying x minus b to be greater than 0, whenever you have something like this and you are told that a is greater than b, so a is the bigger value and b is the smaller value, what you simply do, you solve as though you are equating them to 0. Solve as though you are equating them to 0. So you can say x minus a is equal to 0, x minus b is equal to 0. So x will be equal to a and x will be equal to b. Since a is greater than b, x will be greater than the bigger value and x will be less than the smaller value. So this is how you solve. So let's say I was given a question like this: x plus 2, x minus 8 to be greater than 0. I will solve as though I'm equating them to 0. So in this case, x will be equal to minus 2. In this case, x will be equal to 8. 8 is the bigger value, so x will be greater than 8 and x will be less than minus 2. So that's the shortcut for getting your answer without going through all this stress. Now let's move on to the next question. Next question: x minus 2, x plus 3 to be less than 0. Now for this question, what does it take for the product of two numbers to be negative? What does it take for the product of two numbers to be negative? It is either the first one is positive and the other one is negative, or the first one is negative and the other one is positive. That's what it takes for the product of two numbers to be less than 0. Less than 0 means it's negative, greater than 0 means it is what? Positive. Now positive, negative. Positive, negative. So I can write it is either x minus 2 is greater than 0 and x plus 3 is less than 0. So this is one of the solution. The second solution is that this guy will be less than 0 and this guy will be greater than 0. Now for this, x minus 2 greater than 0 will give us x is greater than 2 and this is x is less than negative 3. Now, for what value of x will you have, or for what range of values of x will you have values greater than 2 and also less than minus 3? Values that are greater than 2 and less than minus 3. So if I pick some values now, greater than 2, values greater than 2, they are what? 3, 4, 5, 6, 7. Pick values less than minus 3. You have minus 4, you have minus 5, minus 6, minus 7. You see that when I list all the values greater than 2, there is no point that those values greater than 2 will also be less than minus 3. Also, when I list values that are less than minus 3, there is no point that the values that are less than minus 3 can be greater than 2. So it is obvious that what I have here is what? No solution. No values of s is greater than 2 and at the same time less than what? Minus 3. And we can check that using our number line. So if I draw my number line here, here is negative 3 and here is 2. S is less than negative 3, less than your negative 3 will go to the left. S is greater than 2 will go to the right. So you can see that there's no point where s is greater than 2 and at the same time less than minus 3. There's no point where this guy is meeting. So what we have here is what? No solution. Now we'll go to the next case where this guy will be negative and this guy will be positive. Now let's look at that. X minus 2 negative, that means x minus 2 is less than 0, and x plus 3 positive, that is x plus 3 is greater than 0. So for this case, x will be less than 2 and for this case, x will be greater than minus 3. Now let's list out the values that are less than 2. You have 1, 0, minus 1, minus 2, minus 3, minus 4 as the case may be. Let's list out the values that are greater than minus 3. You have minus 2, minus 1, 0, 1, 2, 3, 4, down to infinity. This one down to negative infinity. Now, where do I have range of values that are less than 2 and at the same time greater than minus 3? Less than 2, greater than minus 3. Those are the values that are between 2 and minus 3. You can see them here. Values between 2 and minus 3. So you can see them here. So if I'm to draw this on my number line, this is negative 3 and this is 2. X is less than 2 from here going to the left. X is greater than minus 3 from here going to the right. So you can see values of x that are less than 2 and also greater than 3. You can find them here between 2 and 3. And if I'm to redraw it, I can pick here to be negative 3, pick here to be 2, put this and draw a line. So these are the values of x that are greater than minus 3 and also less than 2. And can I combine this type of inequality? Yes. So the solution to this type of inequality is negative 3 is less than x less than 2. Negative 3 is less than x less than 2. So that is the solution to this question. So you can see that when the product of this guy was greater than 0, the answer was x is greater than 2 and x was less than minus 3. But now x is less than 0, your answer is between negative 3 and what? 2. Now, what if you don't want to go through this stress? You want to follow the same approach we use here for OBJ question. How do you go about it? Now, you have a question on the day of your exam. X minus a, x minus b is less than 0, and you are told that a is greater than b. If a is greater than b, solve as though they are both equal to 0. So that is x minus a is equal to 0, x minus b is equal to 0. In this case, x will be equal to a and x will be equal to b. Because a is greater than b, b will come first, less than x, less than the bigger value. As easy as that. So if I have a question like this, x minus 2, x plus 7 to be less than 0, I'll simply write for this case x is equal to 2, and for this x is equal to negative 7. Smaller value first, negative 7 less than x less than 2. That's the solution to the question. Now you've seen how you approach questions under quadratic inequality. That means you first of all factorize, get to this stage. After getting to this stage, this is how you approach the question. So you don't mistake this for this is greater than 0 and this is greater than 0. You should note that it is either these two are positive or these two are negative. In this case, it's either one is positive, the other one is negative, or this is negative and this is positive. Or you just use the shortcut to get your answers. Thanks for watching this video. If you found it helpful, use the like button, subscribe button, share button, and don't hesitate to leave your comment below. Thanks for watching once more. See you guys in my next video.